All right, well, let's move a whole lot closer to home. I wanted to do a quick update on both opportunity and curiosity. So today is, we're rapidly approaching day 4,000 on Mars for opportunity. Last month we celebrated the 11th anniversary of the landing. And I always like to remind people that it was intended to last until April of 2004, a 90-day mission. So we're coming up on day 4,000, as I said. So just to remind you of where Opportunity has been, this was its landing site in this little Eagle crater. It's been driving for 11 years to get to the rim of Endeavour crater. This is about a 20-kilometer diameter impact crater, and right now it's sitting down in this area on Endeavour. And I'm not expecting you to read these, but maybe you can see this little bit of a line. This is a close-up view from Mars Reconnaissance Orbiter of the path that Opportunity's been following. And right now it's sitting about right here. I think we have a closer view here. So this is where it was about 2 weeks ago or so, 2.5 weeks ago. And what they're intending to do is drive down to this crater, Spirit of St. Louis crater. And at that point, they will have, on their odometer, met the distance of a standard marathon, which is I think 42 point, I'm thinking in kilometers. It's like roughly 42 kilometers. But that's where it will have reached that. And then they intend to drive into this, what's called Marathon Valley. And from orbit, they've got the evidence from spectrometers that there are a lot of clay minerals inside Marathon Valley. And what's exciting about clay and sort of the underlying theme of this mission is follow the water. And clay is the type of mineral that you get when you have pre-existing rocks and they get wet. And the rocks essentially rot into clay, if you will. And so they're looking for evidence of that. So just a couple recent images. This was taken last week. Here's the rim of the crater, the inside, the interior of the crater, and so I'm looking out the rear view mirror, if you will, the tire tracks left behind. And this is looking off in the other direction. So Marathon Valley would be on the other side of this ridge. This is actually the interior of Endeavour crater. And so that's what they intend to do. If you're regulars, I've been reporting on the problems they've been having with the memory on board Opportunity, where it's become corrupted, or at least some section of it has, probably from radiation damage. And what they've been intending to do is essentially reformat the memory. It's the same as what you might do on a disk drive on your home computer, that you can map out where the bad sections are and avoid them. And you don't lose any data other than what's sitting right in those sections. But the symptom of this problem has been multiple times a day, the computer on board basically reboots itself. And then it loses everything all the data that it's collected up to that point, and so they can't operate normally. And so on Monday of this week, they updated the onboard operating system, if you will, for the onboard computer. They're in the process of testing out the new software load, and by they think the end of next week, they'll be ready to block off or mask off the bad part of the memory. And before they do that, they want to make sure that the software is operating correctly, other than the memory part of it, and then they'll do that update. And so hopefully, once that's done within the next few weeks, after they've tested this out, then we'll be back to normal operations. And the way it would normally operate is in early morning, Mars time, The Earth communicates with the rover, gives it its commands for the entire day. The rover does whatever it's told to do, whether it's driving, take images, measure some rocks, and it stores all that on board. And at the end of the day, it transmits the data to one of the orbiting spacecraft, and then the data get transmitted back to the Earth. And then they do that day after day. The main thing that changes throughout the week is on weekends, they give it a 3-day load of commands, usually on Friday morning, and it operates then until Monday morning. So hopefully they'll be back to doing that. And so here's just the recap for Opportunity. Again, it's day 3943 since landing. So it's driven 42.05 kilometers. So now I remember it's 42.195 is the standard length of a marathon. So we're just a little less than 200 meters short of that. And so far it's returned just over 200,000 images. Okay, so let's look at the other side of Mars, where Curiosity is investigating the surface. So for Curiosity, it's day 909 today since landing. It came down in August of 2012. And this is sort of a selfie that was taken about a month and a half ago, where Curiosity can hold its arm out in front of it with a camera on the arm, and it does a mosaic, and so you see everything other than the arm itself. And so that's the area that it's been sitting in for the last couple of months, and we'll talk a little bit more about this in a couple of minutes. So again, just to refresh people's memory where Curiosity is, it's sitting inside Gale Crater. This is about a 160 kilometer diameter impact crater. In the center of the crater, there's this large mound of sedimentary rock. It's about 5 kilometers high, and that's called Mount Sharp. And this ellipse was the targeted landing site, and it came down very near the center of that. So what they've been doing since landing is slowly driving off here to where they could get to the base of the mountain, and then they're going to be, over the next multiple years, hopefully, working their way up the side of the mountain. And again, just to remind you what this looks like, this is Mount Sharp from just shortly after the rover landed. And right now, I think they're sitting over in about right here and ready to start coming up the side. This is a much higher resolution view, but you can see why they're excited about this area. There's just all sorts of layers in these rocks, and the standard explanation certainly on the Earth, and we expect on Mars, is that these were laid down sequentially. They're sedimentary rocks, and so by starting at the bottom, you get the oldest rocks, and as you proceed in elevation, the higher you get, the younger the rocks get, and so you can unravel a history of the environment at this location on Mars when these rocks were laid down. And we have lots of evidence that Gale Crater was at one point filled, it was essentially a crater lake, and so these would have been lake bed sediments that got laid down over time. And so again, following the idea that water is what we want to look for evidence of on Mars, and of course the implication for water is that it's involved in biology on the Earth. Every place we find liquid water, we find life on the Earth, and so they're trying to determine if this area on Mars could have supported life at any point in the past. It's just a graphic showing their intended path up the side of Mount Sharp. And this is an overview of where they've been driving. So they landed here, driving along the base of Mount Sharp. So Mount Sharp is down below the stage here. And the reason they've gone so far out of their way is all this dark stuff is thick sand dunes. And they want to make sure that they could avoid that for, they don't want to get stuck in the sand and not be able to move. And so they're in this general area now. This is just day by day view. So here's where they were about a week ago. This is a close-up of their path over about the last 100 days or so. And you probably can't read this, but basically they've been going in circles or zigzagging around in this area. And that's called a geologic walkabout. And so I'll show you a movie in a second, but what they've decided to do is, rather than take a sample and move on, take a sample, move on, is that they do a reconnaissance of an area that they think is related. It's sort of a single unit of rock, and so they can see the way that it's put together. They can do some quick analyses of some of the spots along the way, but once you've done that, then you have an idea of where you want to go back and actually spend weeks and months analyzing particular locations. And so it's a way to, it actually, even though it seems like they're moving very slowly, ultimately it speeds up the process of investigating this area. And let me plug the audio in. Hopefully we'll have better luck than Dimitri did.
Hi, I'm Eileen Yingst. I'm the Deputy Principal Investigator for the Mars Hand-Lens Imager, and this is your Curiosity rover report. For the past several months, Curiosity has been exploring an area known as Pahrump Hills. Up until now, we've been using a linear approach. We always go forward, we don't go back. This allows us to cover the most territory in the least amount of time. That's not how a typical geologist would do it on Earth. On Earth, we'd use a walkabout. That is, we'd walk the site first to get a better idea of what it looks like and use that information to pick the best places for us to do our science. That's what we've done at Pahrump Hills. Curiosity is our robotic avatar on Mars, and as such, she uses her instruments in much the same way we would use our eyes and our hands during a walkabout. She has her cameras on the mast that allow us to get an idea of the area around us. We can use that information to pick a good site for contact science. Once we have that, we can use the MOLLE and the APXS to decide if that site is a good site to take a sample, which we can then put into our onboard laboratory. This more traditional approach has really allowed my camera, the MOLLE, to shine. And I mean that literally, because MOLLE has her own light source. 2 banks of LEDs allow us to illuminate a target in any way and from any angle we choose, including letting us take images at night. This outcrop called Pink Cliffs, which is of interest to us because it has blade-shaped crystals in it. These might have formed when water came through and left behind the chemicals for these crystals to form and grow. MOLLE is the perfect instrument for us to get a great look at these features. The walkabout at this point is now a tool in our toolbox that we can use as we continue our climb up Mount Sharp. This is Eileen Yingst, and this has been your Curiosity rover report. Be sure and check back for more updates.
Okay. So when we talked last month, they had just done their first drilling into the areas in this Pink Cliffs, as they call it. And this was an example of what they'd done. So the first thing they did was come up and just do a test drill where they make sure that the rock is sturdy enough to allow it to be hammered with this drill. And then they come back and do a much deeper hole and collect the dust and pulverized rock that comes out of that, put it in the onboard chemistry experiments, and try and determine the chemistry and mineralogy of the rocks. And so they've collected those samples. They're in the process of analyzing them. This is a close-up view of that sample drilling hole that they did. And this is looking at what they actually did just in the last day. And so they've moved on just slightly. And this is the robot arm extended out, and that little knob right there is the drill bit. And they've actually drilled another hole just in the last day. And so the first thing they do before drilling is they go up with these wire brushes that are on a rotary device. And so that was done a few days earlier. And they brush off the dust, and then they come back and use the drill to drill the hole. And so this smooth area is actually where the end of the drill pushed into the powder and smoothed it out. And so that was an image from yesterday. And so stay tuned. They will be analyzing these samples, and these are the first samples that actually we think are part of Mount Sharp directly. So we should be hearing about that over the next month or so. There's a major science conference in Houston every year called the Lunar and Planetary Science Conference. It's in mid-March, and so I expect there will be a number of talks given about this, and so we should be able to report back on that. Or at least, I think Dimitri will be here by himself next month, and so perhaps it'll be April when I next come back and give you another Mars update. But the reason I wanted to come back to this is the typical selfie that Curiosity has been doing, where it tries to collect the entire rover and just a little bit of its surroundings. But since this was their first stop at the base of Mount Sharp, they decided to try and fill in more of a complete panorama. And so they've done that, and that's what that looks like. And I'm sorry we're not in the planetarium tonight, but when we next come together, we can wrap this around the dome and give you a feel for how it would be to be sitting at this location on Mars. But the main thing to take note of, here's some of this dark sand that they've been carefully avoiding, and there is Mount Sharp off in the distance, and so they ultimately will be heading off in that direction. And again, just to sort of the search for life here, I guess if you have a good imagination, you could say that we've found it. Here's Marvin the Martian giving us an obscene gesture, and his little dog Toto. So maybe you can see them better there. Okay, so recapping Curiosity, day 909, it's driven just a little over 10 kilometers so far, but it's already beat Opportunity in terms of the number of images, almost 219,000 images. So the mission continues, and I'll report back when we next get together. So the other exciting event that's about to happen, or it's slowly been unfolding over the last couple of months, is the arrival of the Dawn spacecraft at the largest asteroid in the solar system, actually a dwarf planet called Ceres. And when we last, well, this is just a graphic of this. Dawn has ion propulsion, so it's solar electric propulsion. It ionizes xenon gas and spits it out these nozzles. The advantage of that, it's not a very high thrust, but it can thrust continuously for many, many years and provide a huge change in velocity. And so they've been using that. I think this launched in 2007, and in those little over 7 years since it was launched, these engines have actually been firing for something like 3 years continuously if you tied it all together. So, but they're about to reach Ceres. This, prior to this mission, was the best view of Ceres that we had. This was taken by the Hubble Space Telescope back in, I believe it was 2004. Ceres is about 950 kilometers in diameter. It's large enough that its gravity will collapse the material into more or less a spherical body. And there's lots of good evidence that Ceres has water ice on it. These bright spots they can measure spectrally are water ice. And so this is going to be a very different place than what we've seen with any other objects in the solar system. And so here we were at the beginning of this month. They were approaching Ceres at something like 300 kilometers an hour. So yeah, a prop-driven airplane speed. And this was a view, sort of a rotation over just part of a day. And so at this point, you can sort of start to see that there are craters on the surface. Here's some bright spots that are rotating by. We can't really tell yet what the story is on all of this. So this was the 3rd through 4th of February from a distance of about 146,000 kilometers. About 2 weeks ago, this was the view from about 83,000 kilometers. And at this point, you definitely can tell that it's a fairly heavily cratered surface. There's definitely these bright spots. We still don't know what they are. Sort of the two simple choices would be that there's ice that gets excavated when an impact happens. And so it's sort of material that gets sprayed out in the course of making that crater. Or there's a possibility, there's some thought that there's actually a subsurface ocean on Ceres, and these could be ice volcanoes where you have water erupting onto the surface through fractures. And here's where we were, the most recent images that were just released from 46,000 kilometers out. And now we're getting a lot more detail. You see there's a big impact basin. These are the types of craters you'd expect to see that have peaks in the middle of them. We see a lot of that on the moon. We're still not able to really determine what those bright features are. But this is the best resolution so far from that same time, and there's a single crater that has 2 bright spots in it. And so that's got people scratching their heads. And the good thing is it's only going to get better. Here's a graphic of the orbit of Dawn. So that first image I showed you from early in the month was taken from here. Ceres is this dot right there. The one on the 19th was taken right here. Next Friday, what is that, March 6th, is when Dawn gets close enough to Ceres that it's actually captured by its gravity, and so it will be in a fixed orbit at that point. And this is just a table saying how far they will be from Ceres at these different dates. And so here's where we are right now. And actually today was the closest approach until they adjust the orbit subsequently. So they got within about 40,000 kilometers. It's going to be captured in a very elliptical orbit. So it won't be until April that it starts getting closer. They'll be orbiting from pole to pole on Ceres so that they can map the entire planet. And Ceres is only tilted on its axis by about 4 degrees. And so there's not a whole lot of seasonal illumination that you have to worry about. You don't have one pole like you do on Mars and the Earth, that in the wintertime it's in darkness. Then you have to wait until the opposite season to determine what's, when it gets illuminated. And so they expect to be able to map about 99% of the surface over the 18 months that they expect the mission will last. By late this year, sometime in December, they expect to have the orbit narrowed down to about 500 kilometers from the surface. So they want to do the global reconnaissance first, and then as they get closer and closer, they can start filling in those details. So by the next update, we should be in orbit, and over the course of the next year and a half, we'll be doing regular updates on what they've been finding with this mission. So the final spot I wanted to stop was to talk about the Rosetta mission, which has been orbiting Comet 67P CG. It's Churyumov. Sorry. I should not try it if I can't say it right. I need to have it spelled in front of me. It's Churyumov Gerasimenko. So you understand why we say CG instead of that. But back in November, the Rosetta mission dropped off a small lander, which successfully set down on the comet. Unfortunately, it bounced and ended up being in shadow, so its solar panels couldn't charge its batteries. But just wanted to give you a little bit of detail on the nucleus. This was the view as Rosetta approached the comet last August before it went into orbit. And you can see it's a very irregularly shaped object. It's got two lobes, and it sort of looks like, from some angles, it looks like a rubber ducky, but this is the smaller lobe on one end, and there's a neck, and then a much larger lobe. And it's about 4.5 kilometers from end to end. This is just a really nice view that they got last November. Here's the large lobe, the small lobe, and here's the neck with all sorts of smooth stuff in it. What they still don't know is, was this caused by two objects that collided and stuck? Or was it a much larger object? And since the comet, as it approaches the sun, the ices start to melt, and gases and dust are blown off. And it could be that this is the most active area of the comet, and we've just worn away a lot of the material there, and ultimately it's going to break in half. So I expect by the end of this mission, they will have a lot better idea of that. It's just a nice artist's rendering by a local space artist here, Michael Carroll, of Mount Fuji in Japan, and 67p CG to scale. So this was, on landing day, this was a view from the lander itself, and its targeted landing site was somewhere in here. Unfortunately, the mechanisms they had on board, there were harpoons that were supposed to fire, there was a thruster pointed down to the surface that was supposed to hold it down. Neither of those systems worked, and the little lander hit, and it bounced, and it sailed off, they think, in this direction, and it bounced a second time, and I think the next slide here is sort of the area that they have reason to believe that it came down, and it's possibly in this shadowed area. So what happened is it's solar powered, and it had enough battery capacity to last about 60 hours. And in fact, that's how long it lasted. It wasn't able to recharge its batteries. But the tilt of the axis on this comet is such that as the summer approaches this year, they expect there'll be a lot more sunlight reaching into that currently shadowed area. And also it's approaching its perihelion. It gets to within about 1.2 astronomical units, so between the Earth and Mars at closest approach, and the sun will be a lot stronger, a lot more powerful in terms of the output of the solar panels. So they're hoping that the lander will wake itself back up. But just a couple of the amazing things they've been seeing with their close flybys. This is in the neck of the comet, and here's this large crack extending for several hundred meters. So yeah, that was a surprise. They not sure what to make of that, but this is certainly the type of thing they'll be monitoring over time to see if it changes, if there's material venting out of that crack, or if the surface structure is pulling apart there. So it's a fairly unique observation. And so I wanted to take you on sort of a flight close to the comet. They just recently altered the orbit and got within about 6 kilometers of the nucleus, and so this is the view over the last month or so. So they had been orbiting right around 30 kilometers, and so on the 22nd of January, they were about 28 kilometers out. The thing you're starting to see here is jetting. So we've got the ice is sublimating, and and water vapor, carbon monoxide, and dust are being ejected from the comet. So you're starting to see the comet come alive, if you will. This was taken the end of January from about the same distance. Again, some really nice jets. And here we are on the beginning of this month, similar distance. So they're starting to really believe that the neck area appears to be the most active part of the comet. That's where a lot of the jets seem to be emanating from. And so that's going to be an exciting observation if they can actually determine that that's the case. And so this is just a little video of how they've been adjusting their orbit to do this close flyby. And I think it starts early this month. So here's this 26 kilometer or so orbit that they had been in. And then they do a firing of the onboard thrusters and go out all the way to about 140 kilometers and work their way back in, and then do this dive bombing of the nucleus where they get within about 6 kilometers. And that happened on Valentine's Day, and then it flew out to a couple hundred kilometers. And it's slowly working its way back in. They expect that at some point later in the mission they're going to try and do more close flybys, but as the comet gets more and more active, it becomes more and more dangerous for the spacecraft to get close, because it's not really designed to be flying through a jet of dust and gas. And the other thing they're worried about, you see all this speckling. That's not noise. They have some pretty good evidence that that's actually little chunks of ice and dust that are floating away from the comet. So they do not want to get their solar panels covered with this stuff or get hit by a fast-moving object. So they're going to stay farther away from the comet for the time being. And after this was on their way into the close flyby, they got on that date about 120 kilometers, moving in further about 105 kilometers. This is really spectacular. You have the shadow of this part of the comet being cast on the gas jets. And this was taken early on the 14th as they approached their closest approach. And at that point, they're taking 4 image mosaics, and the motion of the spacecraft and the rotation of the comet were great enough that they couldn't actually make a seamless mosaic out of it. So they just left the 4 separate frames here. And here they're coming into a little over 12 kilometers. And then I think the final view that we're going to get up close is off in this area of the comet. So here's from, this is the highest resolution image they've released so far. From about 9 kilometers out. Here's this smooth area that they think is probably heavily mantled in dust. It's got these large boulders sitting on it. Those are about 20 or 25 meters across, so house-sized rocks sitting on the surface, or boulders. They could be boulders of ice. In fact, they almost certainly are. And then here's where they were the next day as they moved away from the comet. And again, as they retreat to well over 100 kilometers. So that was that's the final view that they've released so far, but they're releasing these images typically multiples a week, and it's just a fascinating object that they're able to stay at this thing. The previous comet missions we've done, they end up flying past at several tens of kilometers per second. And so just to avoid hitting the comet or flying into debris and killing the spacecraft, they stand off by multiple hundreds of kilometers for those flybys. And you only get a few minutes of observations. Here, they're in orbit around the comet. They'll get continuous coverage, essentially, over the next 18 months or so. Okay, well that's it for tonight. Just wanted, oops, I didn't update this. So the next, March 25th? Okay, thank you. So that'll be our next 60 minutes, and Dimitri will be taking care of that one. And just to remind you that we record, video record all of these programs, and so this is the website if you'd like to come in and replay anything, or we also have the web links to the individual stories so you can get more information. And also let your friends know that weren't brave enough to come out on the roads tonight. Brave enough or crazy enough, whichever. But we do appreciate your efforts to be with us tonight.